Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. So our today's session is the Oracle Cloud Operations Quickstart, where we will cover the fundamentals of operations in Oracle Cloud and explore some of the tools available. So we'll dive into an automation overview followed by an introduction to tools such as Resource Manager, monitoring, notifications, and audit. I'd like to introduce Winnie Yang and Snell Jane, cloud engineers on the customer enablement team, as the main presenters. And with that, I'll hand it over to Snell.
Thank you, Olivia. So, as Olivia just stated, we're going to be going over the Day One and Beyond Cloud Operations Quick Start deck. To the agenda for today, first goal is to understand what are operations on OCI and just in general in the tech landscape. Afterwards, we will look at how to use and deploy different tools on OCI to help you manage operational tasks. And once we've presented some tasks that we can use different tools to manage, we'll try and figure out how we can scale those operations to manage those tasks at a larger scale. Today, I'm going to be co-presenting with my colleague, Winnie. If you'd like to introduce yourself.
Hi, everyone. My name is Winnie. We've been going through these sessions together. So happy to see people here for Cloud Ops, and I will be taking us through the second half of the presentation today.
Thank you. So with that, let's begin. Familiar slide to people who have been in some of the other iterations of Day One and Beyond. We have the shared responsibility model. This is going through the different levels of responsibility for the customer versus the provider, depending on what type of infrastructure you're using. With on-prem, having responsibility from everything through the physical infrastructure, scaling up to something like SaaS, where the customer is going to be responsible for user access and identity, and then data, and the provider is going to manage everything else. Here we have the complete cloud services slide. This is going to detail the different resources on OCI, and today we'll be taking a little bit of a look at the Cloud Ops section in governance and administration. And then under developer services, we're going to be looking at infrastructure as code. So to our first question, what is cloud operations? For simplicity and the purpose of this presentation, we're going to divide cloud operations into 6 parts, and those are going to be building, configuring, monitoring, protecting, securing, and then governing. With building, we're going to look at tools that will help automate your infrastructure provisioning process. For configuring, we're going to look at Ansible, which once you've built, your environment, you can run tools like Ansible to allow you to use scripts to help run routine operations on your environment. Once you've got your routine tasks taken care of, you want to make sure that nothing's going wrong. So we'll talk about monitoring. Monitoring, we'll use some of the native monitoring tools on OCI, such as the OCI monitoring function, OCI notification tool, and some of the observability and management platform. Next, we'll work on protection, which we'll be using the events and functions. For securing, we'll look a little bit through logging, go through audit logging. And then lastly, for governance, we'll talk about how IAM relates to operations. First, we'll look at scripting and automation. Automation is becoming a more and more prevalent part of the tech landscape. We see things like generative AI and many other developments in the AI/ML field that keep pushing automation. So it's not something anymore that is, far-fetched and not common. It is something that is industry standard and commonly practiced. So a great way to incorporate scripting and automation is through infrastructure as code. And we'll see here that generally there's 6 main benefits you're going to have with scripting. First is controlling deployments. Second is creating a central repository. It's very easy to make sure if you've got a golden image or a standardized set that you want everyone to work from. That can be very easily achieved if you have a central repository banking all your scripts. Scripting is also going to be consistent using the UI, allows for inconsistencies and human error. Scripts do not. If you've run a script, tested it in a test environment, and it does what you expect it to, it's going to do that every single time it's run. Next, using Terraform. Terraform is a tool that is based off of HCL or HashiCorp language, which is going to help you take your code, take your scripts, and convert that into infrastructure in many different cloud providers. Once we've started to use Terraform and infrastructure as code to help us build a base set of automation, we can combine that with other operational tools to achieve true cloud scaling. And the last thing for scripting, and particularly for Terraform, is version control. Terraform has a built-in ledger with the Terraform state file that is going to be a collection of all the actions done on every single time you've ran a job or an API call through Terraform. This is a really powerful tool that is going to self-document all of the changes you make to your environments. For monitoring and management, we're going to look at the OCI monitoring. And for those of you who are somewhat familiar with OCI, maybe you've created a compute instance. And when you went into your compute instance and, I don't know, let's say you put a web server on there and you've got some rudimentary web app running, you'll be able to look on that instance in the UI and you'll maybe see number of logins, you'll see CPU usage, and you'll see a handful of metrics that are just going to be tracked there for you. Because there's so much data going in and out on OCI, Oracle tries to take some of the known valuable data points and gather them for you, so that way you'll have them automatically and just easily visualized. For logging, anything that you do on OCI is going to be logged. If someone tries to log in, someone fails to log in, once you've logged in, you click on a certain field, certain folder, certain type of infrastructure, all of those things are logged. You create a resource, destroy a resource, it's going to be logged. So you'll have the ability to look backwards through a lot of the actions that are done on your tenancy through logging. Notifications and alarms is an extension on top of logging, because every time an action is done, it's going to generate a log. And when that log is ingested, you might want to say, I want to know about this. Let's say someone is deleting resources, deleting compute resources. And if someone deletes a compute resource, you'd like to know, well, that's what the notifications and alarm system is for. When you set up an alarm around someone deleting a compute resource, then when the logging system ingests that log, there will be a way for you to create a warning message saying, hey, this action occurred. And then lastly, we have Resource Manager, which is going to be standards-based infrastructure automation, which is going to be based on the Terraform code base. For those who are familiar with Terraform, you can think of this as a secure remote state for your Terraform scripts. For those who are not as familiar with Terraform, I'll revisit this point after we go through a couple slides on Terraform. So back to infrastructure as code. Infrastructure as code is a really big part of operations because it's extremely efficient. Once you've created good infrastructure as code, you get to define an end state and have a tool manage it all for you. Self-documenting infrastructure, I cannot stress enough how important this is. Every single time anything gets done, you don't have to spend any effort. It's automatically logged for you. It's going to be preserved in that state file. And if you ever need to see why something is potentially not working, you'll have all the records telling you what's been done. And you get that for no effort. Consistency, repeatable results. It's fairly self-explanatory. You write one script and you get an infinite number of uses as long as you continue to use that configuration. And you get to increase your efficiency while reducing risk. So, Winnie, I've got a question for you. Based on some of these benefits of infrastructure as code, why is having infrastructure as code and a central repository so beneficial to your cloud operations?
Great question, Snow. So having a central repository means, you can save your infrastructure as code scripts and be able to reuse them. So, people working with these scripts, they can use them over and over again. And what that does, it helps to save reusable code, but also it helps provision your resources in a much easier way.
Right. And so on top of the ease of access and ease of use, if everyone is pulling Terraform scripts from the central repository, then, all of the actions done on your tenancy are going to be added to this ledger. So it's going to give you a very complete view of all of your operations being done through infrastructure as code on your entire tenancy. Here we see the OCIO BTNAS tenancy that we've looked at in a handful of the other day one and beyond sessions, and we see resource manager is parked underneath OCIO BTNAS. That means this is a tenancy-wide resource. When you're using resource manager, you can create scripts in a certain compartment, you can create a job in a certain compartment, but the overall service of resource manager is something that is enabled tenancy-wide. So now we'll go a little bit more in depth into resource manager. A resource manager is a free tool on OCI that is going to manage your resources using Terraform. And so we see here we've got, developers and DevOps, your architects and IT ops. All of these are people who would like to use resource manager. And part of what's nice about resource manager is, number one, if you don't have Terraform on your local PC and you don't want to have a developer image where you're running all of these APIs, then Resource Manager will allow you to run those APIs directly from the console. And one of the big advantages of that is usually when you have, API keys and stuff like that, you have to give those keys to people. So you're putting a API key on someone's local computer. And that's just another resource that is sensitive that you have to manage. Resource Manager is integrated with OCI's IAM, Identity and Access Management. So you can just give the permission out to Resource Manager in accordance with whatever roles you have for your tenancy. And what that effectively means is Resource Manager is as secure as you've made your OCI tenancy, which should be very secure. So it is a good way to securely hand out API access to your users by doing it through Resource Manager. And here we're going to run through the Resource Manager execution plan. First, we're going to run a plan job. What a plan job is going to do is it's going to look through the code. It's going to tell you what the plan is for affected resources. So let's say I'm spinning up a compute instance and a network and a couple of network resources. So it'll say, hey, I'm going to spin up these resources. I'm going to change these resources and I'm going to delete these resources based on what's in the config file. And it'll do that in less than 5 minutes. I've personally never seen a plan job even take more than 2 minutes. The reason this is important is because sometimes plan jobs will fail. And if your plan job is going to fail, then your apply job, which actually creates the resources, is almost certainly going to fail. And an apply job can take a very long time. Let's say you're trying to provision like a whole rack or something like that. That could potentially take 12 hours. And the way Terraform works is it goes through the script in the order that it understands it should provision the resources. So let's say there's a network and a network dependency. Terraform is very intelligent, so it's going to provision the network first and then the network dependency. And then afterwards, it's going to move on to the next step until it's sequentially finished the entire job. But if it fails midway, then it just stops. It doesn't, it doesn't clean up. It doesn't do anything. As soon as it reaches a point where there's an error, it stops provisioning. It returns an error message. It returns the state file of the things it's already done. And then you have to choose whether you want to destroy the stack and you want to figure out what the error was and start from scratch, or try and fix things and then rerun the job with some of the infrastructure already provisioned. But the point is that if it stops midway through, a 12-hour job, that's 6 hours down the drain. Whereas if that error had potentially been caught in the plan job, then instead of 6 hours, you're only out 2 minutes. So I highly recommend running the plan jobs, even though it's not technically necessary. You could just run an apply job. Some other benefits to working with Resource Manager is because, once again, it's synced with IAM, you don't have to put as much information in the Terraform provider file. So if you're, as you can see here, if you're using open source Terraform provider, you've got to have your private key path and your private key password, your API fingerprint, etc. So there's a lot of really, really sensitive data that you need in your configuration file. And ideally, the less sensitive data you have lying around, even if you've got it secured and encrypted, the better. Because, let's say you update your config file, you forget to update it. Let's say your encryption gets old, you're not rotating your keys, whatever. It's just a lot of things that can go wrong. And if it's on your tenancy, you avoid all of that because you've synced it with IAM, and your security on OCI is going to be updated. Encryption is updated by us all the time. So before I hop into the console for a quick demo of a resource manager, we're going to take a look at audit. So audit is the logging service. Everything that you do on OCI is going to be logged. These API calls are all going to be logged. For your events, once again, still all logged. For your log dumps, the events will be available within a maximum of 15 minutes. And for the log history, by default, it's going to be stored for 90 days. You can configure that up to 365 days, so 1 year. After that, back them up to object storage, put them in some other sort of storage if you need them for longer. That's fine. And so here they're also searchable via the console. So there's a tool called Log Explorer, and that's where you'll be able to search for logs. You can search by user, you can search by range of time, etc. And so with that, we'll quickly hop into the console. So here we are in the OCIO BTNAS tenancy. So I'm going to type in Resource Manager in Services. So you're going to see it's going to come up. In the Resource Manager overview, get a handful of resources. If you want to take a quick tour, it's like 10 minutes long. And it goes through the whole Resource Manager at a very high level. Explains what a stack is, which is what your configuration file is. It shows you what to run for the different API calls all the way up through provisioning. It's definitely a nifty little tour if you want to just get your feet wet with Resource Manager and Terraform. For getting started, you have some documentation links here. In Create, here are links to the Architecture Center. These are some pre-configured scripts that you can choose to run on your own. And then lastly, at the bottom, we have some tutorials. So I'm going to go to Stacks, and we see here in our infrastructure compartment, we have the Vision Corp standard compute instance. So this is going to be a stack that's going to have the specific image that meets the correct standards for a compute instance. And if we click into this, we can see here that there's been some different jobs that have been run, handful of plan jobs, an applied job, all of which have been succeeded. And if we clicked on any of these, we'd be able to look through the state file, just in case there's anything that is a little sensitive. I'm going to refrain from clicking on these. But if you did click on this and you click on something like view state, or you can also import state files from other files, this is where you would find that information. So here at the top, we see plan, apply, destroy, more actions, import state, run drift detection. So drift detection is another great feature of running Resource Manager on OCI. Terraform is not an all-knowing tool. Terraform is very smart, but it doesn't know everything. And by doesn't know everything, I mean it doesn't know anything outside of the code you've given it. So if you have a compartment that you spun up with Terraform and that you created like a couple of resources in, Terraform knows all about that. If someone then goes in on the console and they provision some stuff through the UI, Terraform doesn't know about any of that. Terraform doesn't have access to any information on your tenancy. It only has access to the scripts you provided. So if you run a drift detection report, let's say a new job you did failed and you're thinking, this shouldn't have failed. Maybe someone fiddled with the compartment. You can run this drift detection report. You can see the differences and you can start troubleshooting from there. Another really cool feature with Terraform is the ability to reverse engineer already provisioned infrastructure as code. So let's say I'm not really the savviest coder and I don't know how to code in Terraform, but I would like to have a certain instance that I can use. So I'm going to go create an instance. And we see here, you can choose your shape, choose your image, whatever. And then at the bottom, we got this button, Save as Stack. And what that will allow you to do is exactly what it says. You can save the configuration that you choose as a Terraform script, which you can then put in Resource Manager and then run a bunch of times instead of having to reconfigure all the options from scratch. So with that, that's the demo on Terraform and Resource Manager. I will pass it back to Winnie to go over the second half of the presentation.
Thanks, Noah. All right, so sharing my screen now, you should be taking a look at OCI monitoring. So now we're going to dive into monitoring, notifications, events, things like that, a little bit different from what Sunil covered. So first, we're going to take a deeper look into OCI monitoring service. So we have a diagram here, and it basically shows the flow of metrics and alarms. The service itself, it can perform active and passive monitoring of cloud resources using its metric and alarm features. So it keeps track of, how things are functioning, and if anything does come up, the alarm function will step in. So at the very left-hand side, that's kind of where you start. So services such as compute or autonomous database, they will continuously emit metrics to this monitoring service for passive monitoring. And then the alarms will use these metrics for active monitoring. So the alarm will have a trigger action and notification method. So the alarm trigger gets triggered when metrics breach that alarm threshold that you set up. And at that time, a notification will be invoked and pushed. So speaking of notifications, that is exactly what we will talk about next. So the notification service, these have different channels to be used for pushing notifications. So it can be email, HTTPS endpoint, it can be Slack, PagerDuty, and some other third-party applications. So Sunil, I have a question for you. what are some commonly used services to pair with the notification service?
So for the notification service, you can pair a handful of different things. You can have your notifications paired with some of the internal OCI services. You could use it with budgeting, or you could pair notifications with something like the service connector and push them to other monitoring applications. So it's flexible depending on what tools you're familiar and what tools you want to use.
Yep, exactly. So the notification service, it can be integrated with the monitoring service as well, which we saw previously, to send notifications to its notification channels. So the notifications will broadcast messages to distributed components through a publish and subscribe pattern, and it ends up delivering secure, highly reliable, low latency, and durable messages. So these notifications are really used to just get notified when event rules are triggered or alarms are breached, or to even just directly publish a message. So this service enables you to set up communication channels for publishing messages using topics and subscriptions. So when a message is published to a topic, the notification service will send the message to all of the topic subscriptions, which are basically the recipients of the message. So you don't necessarily need an alarm to use the notification service. You can also just set rules or use event services to trigger it. So in the case that a subscriber's endpoint does not acknowledge, receipt of the message, the notification service will retry delivery. So this might happen if the endpoint is offline. So for example, maybe the email server for an email address could be down. So that might be a situation where the message can't go through, but the notification service will try again to try to push that message out after a little bit of time. All right, so next we have our event service overview. So we will go over this and just talk about how you can utilize this on OCI. So this service is essentially an event routing platform. There are going to be 3 core concepts that have to do with this specific event service. We have events. So these are structured and schematized messages that denotes a change in a resource. We have rule as another concept. This is where the object where a user defines which events they care about and triggers an action if it occurs. And then lastly, we have action. So this is the user-defined response when an event occurs. So something like triggering a function, writing to a stream, triggering notifications. Those are all examples of actions. So you can see in our diagram here on the left-hand side, we have our OCI resources that can all trigger an event. So it could be something like a lifecycle state change, or a create, read, update, or delete operation that occurs. And the event rule that's defined by the customer states, what action will be triggered once an event occurs. So, those are actions on the right-hand side. So as I mentioned before, it can be either publishing a message to a stream, sending notification, or invoking function to perform an action. So events are going to be cloud native computing foundation compliant, and they also can be accessible through the console, REST APIs, SDKs, CLI, or even Terraform. So we'll take you, so I already took you through this little event flow, but I'll also take us through kind of how it works in the console as well. But before I do that, I do want to talk about functions and that service. So Oracle Functions, this is our serverless computing platform. You don't need to worry about underlying infrastructure here. all you have to do is write your code, deploy, and then call your function. So it really makes it easy to build cloud native applications this way. You can invoke functions via this event service, like I mentioned before, or you can also use the FN project CLI, Oracle Cloud CLI or SDKs, or even make a signed HTTP request to the functions endpoint. And so because there are actually no servers to provision, the platform is actually able to auto scale. So you would only be paying for the execution and none of the idle time. So Snil, what's an example of, what a common way to use Oracle functions in your environment?
So Oracle functions, can be used to do any API call you want. However, on the topic of operations, a common way people have used functions is to make enforced budgets. So earlier with notifications, we talked about how you could have a notification on a budget. Well, if you don't just want a notification and you want to make sure that you have actual, guardrails in place, you could use a function that could lock down your resource provisioning when that budget is triggered.
Yep, that's a great example of how you can use functions to take an action. So yeah, in addition to something like making an enforced budget with functions, you can also extend SaaS applications with functions. You can use it for ETL. You can send logs to third-party applications or also enforce compliance through auditing security policies. So we have covered quite a bit of the cloud ops, just different, toolings that are available. So I wanted to just revisit our architecture diagram here and just show you where these tools kind of live in your environment. So things like resource manager, auditing, notifications, events, these are all tenancy-wide. So that's why they exist outside of the region. They will be available to use across multiple regions since they are tenancy-based. All right, so I'll be going into the console to just talk about event service and notification service and how you can get that started and how it really comes together to work. So let me go ahead and share my screen. So I'm in the Cloud Console now. This is the homepage. So first, what we're going to do is get our notifications set up. So I mentioned earlier, it does follow a publish and subscribe pattern. So we'll create our topic as well as our subscriptions. So we'll head over to the menu button here, and notification service is under developer services. So we'll head over there and it will be under, let me see, application integration. So we'll just go ahead and click into notifications. Alrighty, so again, as with many tools in OCI, it does matter what compartment you're in. So for me, this is not the compartment I want to be in. So I will go ahead and choose the one that I want. All right. So this is the correct compartment. I'll go ahead and show you how to create a topic. So super simple process. What you'll need is a name for your topic and also a description. And then you can go ahead and create your topic. So let's take a look at an existing topic here called VC content notifications. You'll see, topic information. And under that, you'll be able to see all the subscriptions that belong to this topic. So currently, all of these subscriptions are emails. But if we go ahead and create a subscription, you can see that in the protocol section, you can actually choose between, the different channels that we went over during the presentation. So email is obviously one, but you can also use functions, HTTPS, PagerDuty, Slack, and also an SMS. So if you're using email, you would just enter the email that you want to use to push notifications to. And then you can just go ahead and create your subscription for this topic. So that's how you would set up your subscriptions. So after you actually set up your subscription, what happens is OCI will send an email notification to that email you just created under this topic, and it would just ask them to verify that this is correct. And then once they verify that on the subscription end, then they will become an active subscription like the ones here. All right, so now that we have our, subscriptions up and running, our topic, now we can start using them with event service. So that's where we're going to head over to next. We're going to go back to the menu button and then head over to event service, which is under observability and management. And then, okay, so it's right here, event service. So I'll click on that. So what we're going to do is set up a rule. So we have one active rule here. I will talk about it in just a little bit, but I do want to show you how you can create a rule. So as a refresher, these rules trigger actions for selected event conditions. So the first step would be to enter a display name. And so next would be to input a description for what this rule does. And then here, this is where the fun really begins. You can set up your rule conditions. So limiting the events that trigger actions. So there are a few different types of conditions that you can take. So one is event type, but you can also filter tag. So we'll go with event type today. So event type will need a specific service for you to select. So you can choose, all the different OCI services that are available to you here. I'm just going to choose object storage for the sake of the demo. And now you can select event types that you want to define this rule condition with. So if I click into event type, you can see that, any of these actions such as creating a bucket, deleting a bucket, or updating a bucket, and same goes for objects within the buckets. You can set them as part of the rule condition. So you can also set up more than just one type of event. If I want to, mix and match, I can definitely do that. And on the right-hand side here, this is where you can see the rule logic in JSON format. And if you wanted to, add additional rule conditions, you can also add more here. And once you're kind of satisfied with setting up your rule conditions, then you can set up your actions. So now, once the condition is met, what action is going to be taken. So you can choose from 3 different ones as we saw on the slides. So one is streaming, notifications, or functions. So we're going to just go with notifications and also show you, how that notifications service kind of comes into play here. So we're going to go ahead and choose that compartment we were looking at earlier, which is shared services. So let me just get to that one. And so based on this compartment selection, then I can see the topics that live inside that compartment and be able to choose one. So for us, if you remember, there was only one topic. So I'll go ahead and click on that. If I wanted to add another action to be triggered by the event condition, I could do so as well. But once I hit create, then, any event that meets the conditions that you've set up here will end up triggering this action. So all the emails that you saw in that topic, they will receive notifications and emails from that specific action being taken. So I'm not going to hit create, but this is essentially how you would get that started. But I will show you, what that notification looks like. if the event is triggered. So let me go ahead and share my screen. So this is an actual notification email that I received from an event. So this event type you can see here, it was because someone created a bucket in object storage. And so my email was actually part of that topic. So when someone did that, I received a notification about it. This is what you would see when it comes to, you know, what that notification would entail. So you can see the event type, exactly what happened, at what time, and also the details for the specific action being taken. So things like the compartment ID, compartment name, resource name that was created, and etc. So you can see like all the tags and additional details as well. At the end of this email, you can also stop receiving notifications from this topic. So you could unsubscribe at any time by clicking on the link at the bottom of your email. And so that's also an option for you if you do want to take yourself off that topic. So that's essentially our notifications and events demo. Yeah, so I think we're finished up on our presentation now. So I will pass it to Olivia.
Awesome session. Thank you, Winnie and Sunil. Really appreciate your time and help with this session. I hope it was a good learning experience for everyone.
Quickly show the other events that we are starting under the Day 1 and Beyond series. I will share my screen. Okay, so here is the Day 1 and Beyond screen where you access these webinars from. So go ahead and register for the 3 upcoming webinars that we are going to have for the rest of the year. We will soon be starting the 2024 version of the series. We have the workshop. So the next workshop is an Apex workshop that you can sign up for, which is happening in November. And then we'll have another one in December. You can find the details here, so you can probably bookmark these. We started our Cloud Native Launchpad series yesterday. So we already have 1 session under our belt. We'll have 5 more under this. So if you want to learn about infrastructure as a code, then please go ahead and bookmark these ones also. Then we'll be adding 2 more series starting next year. So stay tuned and keep watching this page. And thanks, Olivia, Sunil, and Vinny for a great session. And thank you, everyone.